So I'm going to do a little demonstration of the Hamann Automat S. As you can see, I have here a part. Probably could have moved the carriage a little closer to get both in frame easier, but anyway, I took the carriage off because I wanted to show a little bit of how simple the mechanism is on this. The Hamann Automat S is a fully automatic machine, and it has automatic multiplication and division. And the way that they were able to do it is, I found it quite impressive actually, how simple they were able to get the mechanism. Still have that automatic functionality. So to kind of take a look at the bottom of the carriage here, and there are two main parts of the carriage here that allow for the automatic functionality. One part is this, and this part is also present on the Hamann Automat, and I would assume all of the Hamanns have the automatic division, which I think is all of them. And this is a release for automatic division. And then these are the other piece. These are sensors for the counter wheels that are used in automatic multiplication. So, I'm not sure if I'll be able to really show this in action, but yeah, you can kind of see it. So if I turn the digit wheel here, see now it's a 9, now it's back to 0. Every time I do that, you can see that that piece there pulls in and out. And that is what trips on the underflow and overflow. So if we take a look over here at the machine, you will see right here, there is this toothed rack. Now, this toothed rack right now is down out of engagement. So this toothed rack up here is the carriage locking rack. So you notice if I push the shift button, you'll see the escapement comes up there to escape the carriage one position along that rack. And this is up to be engaged with the carriage. This rack right now is down. And you'll notice that on this rack, the teeth are, basically half spaces compared to this rack. And this is used in the automatic division. And how this works is if you switch this to division mode, notice how that comes up, the normal carriage rack comes down, and now this is engaged with this, and that holds the carriage in position. This is the normal carriage, as you can see, that's attached to the carriage release lever. This is what engages with that normal carriage rack. But for division, you'll see it retracts the normal carriage rack and extends the division rack. Now this is what holds the carriage in place. And at the same time, this is also what turns the machine on. So see if I can pull this. Yeah, see, this is spring loaded. So if I pull this over, watch the clutch here. See that? So anytime there is pressure on that division rack, the main clutch is engaged, and the machine adds or subtracts depending on which position it's in. So basically, for a division, the machine will shift the carriage all the way over, let go of it. It will that latch on the bottom of the carriage will be in the first position here. Pull this over and engage the main clutch. The machine will start subtracting. Once an underflow happens, that little catch on the bottom of the carriage will trip. This rack will stop being pushed over, and when that happens, the main clutch will be released, and at the end of the current cycle, when this main shaft gets back to its home position, that clutch will lock in. Also, what happens when the main shaft gets back to its home position, this little finger, you can kind of see right there, that little finger there, that's the carriage interlock. So when the when the main shaft is not in its home position, that little finger is extended into a rack on the back of the carriage, which you can kind of see right down in there. Right underneath these things, you can see those little holes down in there. That is what that little finger engages into. So once the pressure is released off of this, then the only thing holding the carriage is this little finger. And then as soon as the drum gets, I keep calling it a drum because that's what you'd call it in a pinwheel machine. This is not a pinwheel machine. When the main shaft gets back to its home position, this finger retracts, and there's nothing at all holding the carriage. So the carriage moves against spring pressure, which is provided by this little swingy arm here. This is always pulling the carriage this way. So, or maybe I should point that, pulls the carriage this way. So as soon as this main shaft goes back to its home position, the finger retracts. There's nothing holding the carriage, so it's allowed to, this spring here, spring arm, pushes it over now in the next position of this, because, this is spring loaded too, so maybe I should try and explain this more clearly, the actual sequence here. So the machine is subtracting, there's an underflow. The little latch on the bottom of the carriage retracts. This piece, which is sprung this way to the right, is being held this way by the carriage. It's allowed to spring this way. See, is that right? Yeah, and then the carriage will... Actually, I think this starts over here, because the carriage moves all the way over this way. So yeah, that's why. It starts over here. Got this a little bit backwards. I mean, obviously you can't really see this happening as the machine's working, so, you understand how it works, and you kind of have to try and explain it, and I got a little bit backwards, but, yeah, so actually the carriage moves over this way to start the division, so it's engaged in this latch over here, pulling this way. Then there's an underflow happens, that little finger retracts, this piece is allowed to spring this way. Now that little finger on the bottom of the carriage is engaged in the second latch, but the carriage is not able to move, and the carriage is not pushing this over far enough to engage the clutch. So the main shaft at the end of the cycle comes to a stop, the finger retracts. Now, with the finger retracted, this, under spring pressure, is allowed to push the carriage over, and again, now the only thing holding the carriage is that little tab in the second latch here, so the carriage is allowed to move far enough until this stops it. And again, when this stops it, it engages the clutch again. Now the machine would be adding until the overflow happens, and then the process repeats. When the overflow happens, the tab lifts up. This is allowed to go forward to lock the clutch in. The finger retracts, and the carriage jumps over again. And that process repeats all the way until the end. And then in the very end of division, the little tab would be over here, not engaged with this. So this, permanently allows the main clutch to engage and stops the machine, and that's it. So it really, if you think about it, it's amazingly simple, compared to other machines where, you have to have a trip on division that then reverses the machine, and then once that's done, then it has to shift the carriage, engage the shifting clutch to shift the carriage. By comparison, this is amazingly simple. Basically, all they had to do was add that tab on the bottom of the carriage, which is just connected to the carry trip here. So each wheel has this little hammer. You can see me wiggling this one. So when the wheel goes from 0 to 9 or 9 to 0, this pushes back, and then it engages with these little tabs down in here, which are the carry chips. So these detent back, and that affects the carry from one column to the next as the main shaft is turning around. All they did was they took the one on the last position, and you can see how it kind of goes over and then back in again. That tab is just on the bottom of this. So this piece right here is, all one piece with that tab on the bottom. So all I had to do is basically make a fancy carry trip hammer for the last position and add a spring to it. Add the division rack here connected to the clutch. That's basically it. And of course the spring for the carriage. But yeah, now this is the Automat S, so it does have automatic carriage movement. So when you push the automatic shift button, it will shift the carriage over automatically. So that's, a little bit more of a complication there. But as far as the actual division process, it's amazing how simple it is, really. I think it is anyway. When you compare it to other machines like Frieden and Monroe and, all the other complexities there. And this process here is actually, pretty much the same that they had in the automatic series. I did a video before about the multiplication in the Hamann Automatic 500, and that was, hugely complex, but division in that machine is basically the same as this. It just has this same rack and everything connected to the main clutch there. So yeah, I thought that was pretty simple, so I wanted to share that. Multiplication works on a similar principle. So if you look underneath this, you'll see there is this. Let me see if I can do this without breaking something. Okay, there we go. So I put the machine in multiplication mode, and you'll saw when I did that, the spring thing sprung the opposite direction. So I'm going to have to reset that before I put the carriage back on. But anyway, so basically the spring switches directions, and then now the carriage is sprung this way. And what happens is you'll see these pieces here popped up. And then these are the same as division. They also interact. Let's see if I can. You see the clutch moving. It's not going to move much because it's already tripped. The first time I pushed that over, it engaged the clutch. So it's already tripped, so it's not going to move that much now. But you can still see it moving a little bit, hopefully. Hopefully you can see it moving a little bit when I push on these two pieces. These two pieces, which are this little finger here and this silver bar here, are what interact with these fingers here on the bottom of the multiplier, or the bottom of the counter section of the carriage. Now, let me see if I can show this correctly. Let's see. So if I turn the wheel. So right now, all the counter wheels are in the 0 position, I think. Yes. And you'll see the position of those fingers is all the same. So now I'm going to turn this wheel to 1, and you'll see that the finger now goes to the back. Now I'm turning it around. When it gets to 5, you'll see now the finger's in the middle. And then when it gets to 0, which I can't do that because it's gonna do a carry, which is, there it goes. Then the carry. Now the next wheel's at 9. This one's back at 0. So those little fingers have 3 positions. It has a 0 position, a 4 and under position, and a 5 and over position. And depending on the position of those determines what's going to happen with how it's going to interact with these. So let me see if I got this right. So when it's at 9, this is all the way back. So it's going to be stopped by this one, which is going to put it into a subtraction mode. Because again, on these Hamann machines, addition and subtraction, the only difference is the position of the carriage. So we got these intermediate wheels here. So either, depending on the position of the carriage will be engaged either directly with these main gears or with the reversing idler gear here. So when it's engaged directly with the main gear, that is an addition. When it's engaged with the reversing idler gear, that is a subtraction. So, let me make sure I got this right. So, let me see. Oh, I don't have this right. So actually that's a 1. I was going positive, so it carried over a 1. I was assuming it carried over 9, but no, I carried over a 1. Okay, that makes more sense. So this is in the 5. Actually, let me put this one in. Okay, now we can see everything in all the positions at the same time. So here's the 0 position. Here's the 4 and under position. Come on, focus, please. And then the last one here is in the 5 and over position. Right now it is a 6. So when it's all the way back, it's going to hit this pin and be stopped in the addition position. When it is, slightly more forward, it's going to be stopped. It's going to bypass that pin and be stopped by this bar, stopped in the subtraction position. And then when it's in 0, it's going to be in the front and just bypass everything. So again, we've got 0 towards the front, that bypasses everything. 4 and under in the back, that stops it in the addition position. And then 5 and over in the middle, that stops it in the subtraction position. And both the addition and subtraction put pressure on this assembly. When it's in addition, it's hitting this pin, putting pressure on it and engaging the clutch. When it's in subtraction, it's hitting this bar, putting pressure on it, engaging the clutch. And then I think they have this bar here just to keep them all, aligned as the carriage moves over. You keep them all at 0, just so they don't, I guess, get caught on anything. And then this little spring thing here will push those little fingers back against, those stops, so it makes sure that it's getting an accurate reading off of them. And basically, that's how multiplication works. To do multiplication, first you have to manually use these little thumb wheels to dial your number into the counter, and then you put it in multiplication mode and push the go button, this button here, which all of this does in multiplication is releases a clutch so that the reverse spring can drag the machine, and start dragging the carriage towards the right, which will push those fingers against these and perform the multiplication. So yeah, I mean, that's basically all there is to it. This does have shortcut. So as I was explaining, when the counter position is in 5 and above, it will stop it in the subtraction position, and then as the machine runs, it will subtract and subtract and subtract until it gets to 0. And because it's subtracting and those tens carry on the counter, when it gets to 0, it will increase the next position by 1. And that's how it's able to do the shortcut multiplication. So, there's nothing fancy to remember that, oh, I need to subtract 1 in the next column. No, it just uses the tens carry of the counter to handle all that. There's no added complexity there for shortcut multiplication. So, yeah, I mean, basically to do shortcut multiplication on this, all they had to do was, have that 3-step cam on each of the counter wheels to have those 3 positions, and then add this extra position here for it to happen in subtraction. Okay, so I reinstalled the carriage in the machine. I hopefully have everything installed. I think that I do. So if we move the carriage all the way over and push right now we are in addition mode, push the motor button. It's going to be hard to do. One hand. Too much stuff in the way. That will clear out the carriage. So if you see there's a gear on the end of the carriage here, right now it's engaged with another gear. That's the carriage clearing gear. So right now, if I try to add, move this over a little bit so I'm not interfering. If I try to add, nothing's going to happen because right now the carriage is over too far and it's not engaged with either the main wheel or the intermediate reverser wheel. The only thing that's engaged is that carriage clearing gear, so it'll just clear the carriage. If I want to add, I have to shift over one position, and now you'll see it adds in to the carriage. This does have automatic clearing. I have to put a piece back in here yet to enable that, but you can clear manually with that. And of course, for subtraction, you'll see the carriage moves a half step and then engages with the reverser wheels, and then it subtracts. And then tab over one place, hit again, and it will clear everything out. I do have the counter in reverse, and that's because the counter stays in reverse for both multiplication and division. For division, obviously you're counting subtractions, so you want the counter to count up for subtractions and down for additions. In multiplication, the goal of the machine is to get the counter back to 0, so again, you're counting down for additions, or in the case of shortcut, up for subtractions, back to 0. Or in the case of subtractions, up to 0, and then 1 in the next column. So let's show how that works. So if I'm put the machine in multiplication mode, you'll see a little finger will come up down in here. I think you'll be able to see it yet. No, it's not. It must be underneath this piece. So I probably saw it when I had this off. But anyway, there's a piece that comes up and locks the carriage. So that's what's holding the carriage now, because those other main carriage ratchet racks have dropped down and are out of engagement, and the carriage is now sprung this way, which normally you can push the carriage that way anyway, but it's sprung that way, so there's a finger that comes up to stop it. As soon as I push this button, it will release that finger, and the machine will operate. So let's put a number in. Let's see, 625. And we can set the same thing here. Oops. 625. So now, as soon as I push this, the carriage moves, and it has engaged the main clutch because it's putting pressure on that rack. So it's a 5, so we're putting pressure on the backwards pin, or I should say the pin more towards the back, locking this in subtraction mode. Maybe I have that backwards. But it is in subtraction mode. You can see it is engaged with the idler wheels there and not in line with the main gears. So actually, I guess maybe I had it backwards when I was explaining it. And that silver bar is the subtraction position, and that tooth, that single pin, is the addition position. But anyway, you get the idea. Based on the position of that finger underneath, it will engage with one or the other and stop the carriage in either the addition or subtraction mode based on the contents of this register. So anyway, the main clutch is engaged, so it's subtracting. It gets to 0. Now the main clutch no longer has pressure on it, so you can see it's back pressing against this disc. As soon as this disc gets around, it will re-engage because we have reached 0 here. So the only thing holding the carriage now is that finger that I pointed out that will retract once the main shaft gets to 0. So as soon as this comes around, you can see it coming around here. It's having it both in shot. See, as soon as it reached 0, the finger retracted, the carriage jumped, it put pressure on that rack again, the clutch engaged, and now we are adding. And now as soon as we get to 0, let's see if I can catch this. It doesn't move much. See how it moved a little bit there? That's because the pressure was taken off that rack and pin when the counter reached 0, which it's doing right now. So, yeah, and as soon as this comes around, the pin will retract, the carriage will jump, clutch re-engages, and we're adding. And now as soon as this gets up to 0, because this is a shortcut, it will just carry over 1 to the next column. You can see there, went from 9 to 10. Now this column has a 1. So again, the process repeats. Just because there's a 1 in this column, it gets back to 0. Carriage goes all the way over, and we're done. Now again, because this machine has automatic carriage movement, if I had the motor on, it would move the carriage all the way back to the left again. But that's handled by another shaft down here in the bottom, so I can't do that with my little vice grip here. You see the main clutch is engaged. Yeah, so normally the machine would then take it back to the clearing position, so we can now clear it out and do a division. So for division, we shift to here. We can enter 113. We can enter our main number in the carriage directly with these little thumb wheels. And these little thumb wheels on this machine only work when the machine is in the clearing position. These wheels actually lock on this machine, so if you have the carriage not in the clearing position, you can't turn these at all manually. These have a hard lock on them. I mean, you can, push past that if you have enough force, but you're not going to get enough force on these little wheels to do that. Basically, there's a detent lock where as the main shaft spins around, it will release the detents at the appropriate time and then lock them again at the appropriate time, and then they detent in and lock this. So the only way you can turn these is if you push them hard enough to pop that detent over center and release them, and then they just freewheel. There's no resistance on them at all. So not a good idea to do that, because then what happens is if these freewheel, then they can feel at any position, and then the teeth won't line up. You can see how all these gears are lined up. If these freewheel, these get out of alignment, and then you can't move the carriage because the teeth on the carriage collide with the teeth either here or here, and it's just very bad all around. So yeah, anyway, my point is, don't try to use these thumb wheels any position except for the all the way to the left clearing position. So anyway, we're in division mode. We've got that in there. Again, normally you'd push this button and the motor would move the carriage all the way out. And since I don't have the motor turned on right now, we'll do it manually. So we just move this all the way over, and you'll see as soon as I release this, it should engage that clutch, which it does, because now that little tooth on the bottom is engaged with that half-step tooth division rack, putting pressure on the clutch, so it's engaged, and we're subtracting. We get an overflow, and it jumps. And again, as soon as this happens, it releases that. So you can see right now the clutch is disengaged, or trying to disengage. It's back against the face of the plate there. So as soon as this wheel, the main shaft, turns back to the home position, the clutch will disengage, and the only thing holding the carriage now is that finger that sticks out when the drum is on in the home position. So as soon as this is down to its home position, that finger retracts, the carriage jumps, putting pressure on the division rack again, the clutch re-engages, and we continue. And it just repeats that process. Oops, seem to have gotten stuck there. There we go. Sometimes it gets a little bit stuck, I think, when the carriage doesn't move as fast as it should. I think you might not be in the right position, actually. Yeah, it got a little bit messed up. I'm going to have to see if I can get out of this mode. There we go. Let's start over again. I think it got a little bit stuck there, and then when I pushed it, it re-engaged in the wrong place. So we'll clear it out. Change back to division mode. Put this back in. And again, we're subtracting. That's what happens too. Sometimes I'm probably a bit too much force with my vice grip handle here, and then it jams the clutch from releasing, because basically all that releases the clutch is the spring pressure on the carriage pushing on that division rack, releases the clutch. But if I am a little too heavy-handed here and I turn this wheel around too fast, it can actually put too much pressure on the side of the clutch release in order for that spring pressure of the carriage to overcome it, and that can be a problem too. Which is not a problem for the motor, because as soon as the shaft gets near the clutch position, the clutch starts to disengage, and then there's no more pressure from the drive on it. See, again, I put too much pressure on it, and the clutch didn't want to release just under that spring tension. And that's it. The clutch is locked. The carriage is now in the cling position, and we have our answer, 3.141 from 1992. 3.1 for 15929. Yeah. So again, we can clear that. We can clear this. And yeah, so I think that about sums it up for this video. Basically, I just wanted to show, how amazingly simple the multiplication and division on this is. There's so few parts involved. I thought it was quite amazing, but yeah, I just wanted to demonstrate that. So I hope you enjoyed this video, and thank you for watching.